guys, my name is Deep Kaur and today we'll be focusing on the 2006 AP Calculus AP free response question. Okay, so this, just to tell you guys ahead of time, this whole problem is focusing on to find the volume and the area between the two curves. So let's get started. So number one, so it says, let R be the shaded region bounded by the graph of y equals ln x and the line y equals x minus 2 as shown above. So again, this curve right here is ln x right over here, and this straight line that goes up is the line x minus 2. Okay, so let's get started. So A says find the area of R. So before we get anything started, we first need to find our boundaries. So in order to find our boundaries, we need to graph ln x and x minus 2. So ln x, this line, and this line, x minus 2. And we need to find the intersection points, the point where they intersect. This point and this point. We don't know what these points are. So I would recommend you guys get your graphing calculator out and start graphing it. So I already put in all the numbers. So our first intersection is 0.15859, and our second boundary, if you will go again, press the arrow, our second boundary would be 3.14619. So we need to find these boundaries because these are the boundaries where our shaded region is in. So in order to calculate the area, we need to find our boundaries. So let's write that. Okay, so we're going to call our boundaries, you can call your boundaries x and y or anything, but we're going to call, in this case, we're going to call the boundaries s and t. So let s, so this is not any number. Before you start the problem, this is what you need to do to get your boundaries. So let s, we found out that s, one of the intersection point was 0.15859. And then our other intersection point, we'll call that t, is 3.14619. So now we got everything sorted out. Now we can actually start the problem. So let's go back to A. So A says to find the area of R. Again, we need to know the formula of the we need to know the formula of a shaded region. So I have the formula right here on a post-it note, and the formula is the integral of A to B, big R minus little r dx. Remember to always put your dx in because this is part of the formula. Don't ever forget it because you will be docked out points. So again, the integral of A to B, big R minus little r dx. Okay, so in this case, we're going to have an integral. Our A in this case is s. So s is going to be 0.15859. And our b in this case is t. So t is going to be 3.14619. Okay? So then we got that part done. And now our other part is to get big R. Big R is always going to be on the top, and if you go from top to bottom, we can see that our line that is on the top is ln x. So ln x is going to be the big R, so it's going to be ln x minus little r. Again, if you start from top to bottom, the line that's on the bottom is your little r, so in this case it's x minus 2. So we're going to do minus x minus 2 dx. Don't forget that dx. This is really important because then you'll be docked out points for no reason. So when you calculate that, you put it in your calculator, you will get the answer of 1.949. That's basically it. That's all you have to do. Put it in your calculator and you've got the answer. So let's look at the scoring guide for this letter. So for the scoring guide, there's a total of three points. The first point goes to your integral. So if you have all of this right over here, this is 1 point right over here. And our second point is limits. So basically this and this is another point. And our third point is the answer. So this is going to be our other point. So if you have everything in this question, you have everything, then you'll get all those 3 points. Okay, so that was basically it for this letter. So let's go on to the next one. The next question asks to find the volume of the solid generated when R is rotated about the horizontal line of y equals a negative 3. So they're asking us to find when is when it's rotated around y equals -3. So again, before we do this, we need to find our volume. We need to find the area or volume of a solid. So again, I have the volume formula written down right over here. So to find the volume, this is the formula. It's pi, the integral of a to b, big R squared minus little r squared dx. So let's put everything in, substitute everything. So we're going to have pi right here, integral, a in this case, like I said before, was s, so s is 0.15859, and then b in this case is t was 3.14619, so we got that part. So now we need to do big R squared minus little r squared. So we already know what our big R is and what our little r is. So we just need to square those. So let's do that. So we're going to get, so what we're going to do is we're going to get ln x plus 3. And the reason why we're doing plus 3 over here is because it has to find it says to find the rotation about the horizontal line when y equals a -3. So what this is basically is this ln x minus -3, which turns into plus, because this is the formula. Because we have to do big R minus, because we have to do the big R minus little r. This is part of the formula, so it's going to be ln x minus -3. We just simplified it and we got it. We just added. That's how we got that. Because it says to find when it's rotated around the horizontal line when y equals -3. So when you plug in y equals -3, it turns into addition. So that's that. Squared. And then we're going to get our little r, which is going to be x minus 2 plus 3 squared dx. And then what's the little parenthesis right here? Okay, like again, this plus 3 comes again because we're rotating about the horizontal line when y equals a -3. So that's why it's, reason it's positive 3 again is because it was x minus 2 minus -3, and again it turns into plus. So that's why. So I'm just gonna erase this so you guys won't get confused. But yeah, this is basically our equation right over here. So they're both square. We both have the big R and the little r. So now it's time to get our answer. So once you plug everything in, you're gonna get 34.198, and if you round, you'll get this if you don't round it. But if you do round it, you'll get 34.199. Okay, so either answer works. So let's look at the scoring guide for this problem. So this scoring guide is again a total of 3 points. You get 2 points for your intro again. So basically this whole thing over here, you get 2 points for that. And then you get 1 point for your limit, constant, and answer. So your limits and your answer, which is right over here. Okay, so that's that. So now we're gonna move on to our last problem. Just gonna erase this answer right here and put it right over here, so we have room to do the other problems. Okay, so we have C, our last problem. So C says, write but do not evaluate an integral expression that can be used to find the volume of the solid generated when R is rotated about the y-axis. So now we need to find an integral. We do not need to answer, or we don't need to solve this. We just need to find the integral. So let's start. It says to find the volume of the solid generated when R is rotated about a y-axis. So again, we're going to be using this volume formula. So it's going to be pi, and we're going to have the integral of A, like I said before. A in this case is S, so it's going to be 0.15859. And then B in this case is T, which is going to be 3.14619. So that's going to be that. And then, sorry guys, I messed up. I messed up. Okay, so the problem is asking expression that can be used to find the volume of solid generated when R is rotated about the y-axis. So what we need to do in this point is we need to transform the equation. So we have to adjust the bounds because we are you're changing the value of the x to equal something different. So you have to change the bounds to match with the changes. So we're changing the bounds, so it's going to be t minus 2 since we're making this equation from y to x. So this equation was before it was y, now we're trying to put it into x. So we're changing the bounds t minus 2 and s minus 2. That's why these bounds are minus 2 because we're adjusting because we're changing the whole equation to x. That's why we have to change the bounds. Okay, so we're going to have, sorry guys, our big R, which is going to be y plus 2 squared, and then squared minus our little r, which is going to be e to the y squared dy. So again, we're changing everything into an x form. That's why we have to change the bounds and everything. So again, this is basically it. We don't have to solve it. This is going to be your integral. So let's look at the scoring guideline for this. So this is a total of 3 points. That's why this whole problem is worth 9 points, which is a lot. But this question is worth 3 points. 2 for the integral, this whole thing we just did, all this. And then 1 point for the limits and the constants. So we have the limits right here, and the constants will go along with it. So these are both our limits. And yeah, that's basically it. So basically this whole problem was just the biggest topic basically the only topic that we were going over is to find the area and volume under between two curves. And yeah, that's basically it. And I hope you guys understood what I said. And yeah, thank you.